Hello everyone. In this video, we'll be solving problem 976, largest perimeter triangle. The problem statement is, given an integer array nums, we need to return the largest perimeter of a triangle with non-zero area, formed by the three sides of the length. If it is not possible to build a triangle, then return 0. The rule for deciding if a particular set of numbers can be used to form a triangle is that the sum of two sides should be greater than the third side. In this case, with three sides as A, B, and C, the rule will be A plus B should be greater than C. If this rule is suffice, then we can have a triangle with A, B, and C as the lengths. In example number 1, with the given inputs as 2, 1, and 2, and applying the triangle inequality rule, that is A plus B greater than C, the rule is suffice with the given input, hence we can calculate the perimeter and return it as the output. As we only have three numbers in the input, there are no more combinations we can build. Hence, the output is 5, which is the sum of all the three numbers in the given input array. But in example number 2, we have a total of 4 inputs in the array, which means we can build at least 2 triangles, which could be valid depending on the values. With these inputs, it is not possible to build a valid triangle. Hence, the output is 0. The problem statement is very straightforward and easy to understand, and so is its solution. So now let's switch to whiteboard and discuss how we can solve this problem, starting with the brute force approach, following up with an optimized one. Let's start by understanding how we can apply brute force to solve this problem. As we discussed earlier, we'll be using the triangle inequality rule to decide if we can use the three numbers as the side for a triangle, making it a valid one. So the simplest way to use brute force on this is to try all possible combinations of A, B, and C and verify if the rule is sufficed. If yes, then the corresponding perimeter will be saved into a separate variable which will only be rewarded with a higher value. And after trying all possible combinations, we'll return the max P, that is the maximum perimeter, as the output. Let's do a quick dry run where A is pointing at 7, B is 4, and C is 6, which are next to each other. Applying the formula to decide if this combination will give us a valid triangle. Yes, it will, because A plus B, that is 7 plus 4, is greater than 6, which means we can use it as a valid triangle. So we'll calculate its perimeter, compare it with the max P, and override it if the value is greater. In this case, the perimeter is 17, which is highest so far, so we'll save it in the variable. And now we'll try a different combination for C, where C is now 2. We'll repeat the same cycle of doing the check and calculating if the rule is sufficient. If yes, then we'll calculate the perimeter. In this case, it is less than the current maximum, we don't have to override. After trying all possible combinations for A, B, and C, we'll return max P as the output. With this approach, the time complexity is going to be O of n cubed, as we are trying all possible combinations for A, B, and C to verify if the triangle is valid, calculate its perimeter, and compare it with the maximum perimeter to get the largest one. While the space complexity is O of 1, that is constant space, as we are only using one additional parameter to record the output, that is the maximum perimeter. Now let's discuss how we can optimize this solution to lower our time complexity. Because the rule is that A plus B should be greater than C, instead of trying all possible combinations where the numbers are jumbled up and not in order, what if we first sort the entire array into ascending order and then try to apply the formula? If the entire collection is sorted in the ascending order, we can be sure that the values on the right hand side of the sorted array will be greater than the values on the left hand side. So instead of trying all possible combinations, we can start the iteration from the right, verify if it is a valid triangle, and if yes, we can just calculate the perimeter and return the output. As we are starting the iteration from the right and moving towards the left, every time we decrement the pointer, the value is going to go down. That is the largest perimeter. If we found a valid triangle that matches the criteria, we can immediately stop the iteration and return it, because if we decrement the counter and try to find a different combination, the perimeter of that combination will be either equal or less than the current perimeter. This logic is only possible because we have sorted the array in the ascending order. Let's do a quick dry run on this example by sorting it in the ascending order. Now we'll start our iteration by our pointers pointing at the rightmost elements, considering that as a C, and a couple of elements right before them will become A and B. If we apply the formula with these numbers, the formula is suffice, which means we have a valid triangle with sides 6, 7, and 8 as the values. As we found a valid triangle over here with sides 6, 7, and 8,
and calculate its perimeter and return it. You could have reached the same result if you would have started the iteration from left to right. The only difference would be we'll have to try all possible combinations by incrementing the pointer until the end and compare the perimeter with the maximum p. But as we are using the early termination logic, starting the iteration from the right hand side gives us that flexibility to optimize our solution.
With this solution, our time complexity is now improved to O of n log n. This is because we are first sorting the input array into ascending order and then running an iteration from right to left to find a valid triangle. This n log n represents the amount of time needed to sort the input array, while the space complexity is just like before, that is O of 1. As we are not using any additional parameters to store our results or do the calculation, we are calculating the perimeter if a triangle is valid and returning it immediately. I hope you are able to understand this explanation. Let me show you how we can implement this using Java. In this Java implementation, I start by ordering the input array into ascending order and then start the for loop to iterate through all of the elements in the sorted array. This for loop will start from the right hand side and move toward the left hand side. That is, it will start with a.length minus 3 all the way till 0 while we are incrementing the pointer every run. I have this condition to check if the value at I, that is our A, and the value at I plus 1, which becomes our B, is the sum of 2 greater than the value at I plus 2, which is our C. If the condition is suffice, means we found a valid triangle, so I'm calculating the sum of the three values, that is our perimeter, and returning it as the output. After running through all of the loops and we did not find any valid triangle, then I'm returning 0 as the output. This code, when submitted on LeetCode, beats nearly 53% of the submissions in terms of runtime and 83% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.